Hi, how are we doing? All right, so we're up to Module 10 of Switching, Routing, Wireless Essentials. And so it's the LAN security concepts. So in this module, we're going to look at the vulnerabilities that comprise LAN security, and in particular, endpoint security. So, of course, basically hosts, and then we're going to look at some other issues, and so you can look at access control. So we'll look at authentication through either AAA or 802.1x. We'll also look at layer 2 security threats, so different vulnerabilities that can be attacked, and so we're going to look at some more specific attacks like MAC address table attacks as well as other LAN attacks. So, endpoint security. So of course, there's pretty regularly there's stories in the media about all kinds of attacks going on, and so you can simply Google latest network attacks to find up-to-date information on current attacks. Most likely, these attacks will involve one or more of the following. So, there's distributed denial of service, and so that's where basically it's a coordinated attack from many devices called zombies with the intention of degrading or halting public access to an organization's website or resources. So basically, denial of service means, you make a system so busy or somehow in some other way disable the system so that valid users can't get the services they're required. And so, of course, distributed means you use a large range of hosts to be able to do that. All right, so a data breach is an attack in which an organization's data servers or hosts are compromised to steal confidential information. And then, of course, there's the old favorite of malware. And so it's an attack in which an organization's hosts are infected with malicious software that can cause a variety of problems. For example, ransomware such as WannaCry encrypts the data on a host and locks access until a ransom is paid. And so they call that ransomware, yes. And that's pretty common these days. All right, so security devices, of course, can be used to assist in protecting your networks. And so these devices include virtual private network enabled routers, and so you can provide a secure connection to remote users across a public network and into enterprise network. VPN services can be integrated into the firewall. All right, there's a next generation firewall, which provides stateful packet inspection, application visibility and control, next generation intrusion prevention, and advanced malware protection, as well as URL filtering. And there's also network access control, which includes authentication, authorization, and accounting services, or AAA. In larger enterprises, these services might be incorporated into an appliance that can manage access policies across a wide variety of users and device types. And Cisco Identify Services Engine, or ICE, is an example of a network access control device. And so basically, when it talks about policies there, you can have, what users can do what, of course, but also what is a minimum status for you to actually connect to the network. So that be that up-to-date virus definitions and the like, and patches and things like that. So, all right. So endpoint protection. Endpoints are hosts which commonly consist of laptops, desktops, servers, and IP phones, as well as employee-owned devices. Endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing. Endpoints have typically used traditional host-based security features such as antivirus, anti-malware, host-based firewalls, and host-based intrusion prevention systems. Endpoints today are best protected by a combination of NAC and AMP software, and of course email security appliances as well as web security appliances. And so basically, you've got all your endpoints, and of course they're connecting into the enterprise's network, be that through switches, wireless, and so on. And so from there, you can actually use your firewalls and other appliances to actually help make those hosts more secure, and so from there, your network more secure. All right, so a Cisco email security appliance is designed to monitor mail transfer. the ESA is constantly updated by real-time feeds from Cisco Talos, which detects and correlates threats and solutions by using a worldwide database monitoring system. And so this threat intelligence data is pulled from by the Cisco ESA every 3 to 5 minutes. And so they can block known threats, remediate against stealthware, malware that evaded initial detection, discard emails with bad links, block access to newly infected sites, and encrypt content in outgoing email to prevent data loss. And so, all certainly worthwhile activities. And so with the web security appliance, it's a mitigation technology for web-based threats. It helps organizations address the challenges of securing and controlling web traffic. So it combines advanced malware protection, application visibility and control, acceptable use policy controls and reporting. So it provides complete control over how users access the internet. So certain features and applications such as chat, messaging, video and audio can be allowed, restricted with time and bandwidth limits, or blocked according to the organization's requirements. It can perform blacklisting of URLs, URL filtering, malware scanning, URL categorization, web application filtering, and encryption and decryption of web traffic. Okay, so we're on to the next topic, which is access control. And so, of course, most of that we're talking about is authentication. And so getting back to our routers and or switches, we do have solutions for that. So, so many types of authentication can be performed on networking devices, and each method offers varying levels of security. The simplest method of remote access authentication is to configure a login and password combination on console VTY lines and auxiliary ports. And so as you can see on the top there, we've just set a password, and of course we're enforcing that they need to log in. So of course that's fine, but of course the default for VTY is Telnet, which is not really not fine. Anyway, and so with SSH, it's more secure. And so the first thing the SSH requires is a username password as opposed to just a plain old password. And of course, secondly, of course, it encrypts the data. And so from there in transit. And so, of course, that makes things a lot more secure. And so, of course, you need to generate a key to get that to happen. And of course, version 2 is the better version of SSH. There are some flaws in version 1. And of course, you do login local to enable the username password combination. And by doing transport import SSH, that will only allow SSH. So Telnet won't work on that. Now, local databases are fine, but basically, how many routers and switches will you have in your organization? If there's 5, that's probably right. If there's 500, no, it's not all right. And so basically, user accounts must be configured locally on each device, which is not scalable. And the method provides no fallback authentication method. So you can actually create AAA as being an option, and you can actually have a first option, and if that falls back, you can actually authenticate as a standby solution basically as well. So you should get in. So of course, AAA stands for Authentication, Authorization and Accounting, and it provides the primary framework to set up access control on a network device. It's a way to control who is permitted to access the network, so authenticate, what they're allowed to do, authorized, and audit what actions they performed, sort of accounting. So it's not dollars accounting, of course, it's more logging, who's done what. Okay, so the authentication side. So local and server-based are two common methods of implementing AAA authentication. So the local AAA authentication, again, uses your usernames and passwords stored on the device. Users authenticate against that local database, and that works great for small networks. On larger networks, you can have a centralized or server-based solution. And so when someone goes to authenticate, the router or switch actually authenticates their details, sends the authentication details to the server, which will just say, yes, they can, or no, they can't connect. And so, of course, you have that centralized database on the server for usernames and passwords, and so it's a much easier system to maintain on a larger network. And so the two major protocol options available are Radius, which is remote authentication dial-in user service. That is standards based. And there's also TACACS, which is terminal access control or access control system. That was actually standards based, but as soon as you put the plus on it, Cisco has embraced and enhanced the protocol. So in other words, it's not standardized. And so it does have some extra functionality, but of course, it's a Cisco-only solution. So, and when there are multiple routers and switches, server-based AAA is more appropriate. So the authorization, of course, basically, of course, is controlling who's allowed to do what. And so basically it's automatic and does not require users to perform additional steps or after authentication. Authorization governs what users can and cannot do on the network after they are authenticated. Well, authorization uses a set of attributes that describes the user's access to the network. These attributes are used by the AAA server to determine privileges and restrictions for that user. We won't really be going into that anymore. So of course, accounting is the logging. So collects and reports usage data. This data can be used for such purposes as auditing or billing. So yeah, that's why you can do billing, but of course, that's if you're an ISP typically or someone like that. But of course, for most organizations, it's just to keep track of who's done what. And so the collected data might include the start and stop connection times, executed commands, number of packets, and number of bytes. The primary use of accounting is to combine it with the AAA authentication. And so the AAA server keeps a detailed log of exactly what the authenticator user does on the device. As shown in the figure, this includes the exec and configuration commands issued by the user. The log contains numerous data fields, including username, date and time, and the actual command that was entered by the user. This information is useful when troubleshooting devices. It also provides evidence for when individuals perform malicious acts. Now, when it comes to AAA, it is actually an option on Packet Tracer. And so, yeah, there is actually a Radius server you can use. And of course, that is all very nice. All right, so another authentication option is 802.1x. And so it's a port-based access control and authentication protocol. This protocol restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. And so basically you have the supplicant, which is the client machine. Which of course is what, and so that's either going to be via wired or wireless connections. You have the switch, which is the authenticator, and so it's the intermediary between the client and the authentication server. It requests identifying information from the client and verifies that information with the authentication server and relays a response to the client. Another device that could act as an authenticator is a wireless access point. And the authentication server validates the identity of the client and notifies the switch or wireless access point that the client is or is not authorized to access the LAN or switch services. All right, some layer 2 threats. So of course, layer 2, data link layer. And so basically, network administrators routinely implement security solutions to protect the elements in layer 3 up through layer 7. They use VPNs, firewalls, and IPS devices to protect these elements. However, if the layer 2 is compromised, then all the layers above it are also affected. For example, if a threat actor with access to the internal network captured layer 2 frames, then all the security implemented on the layers above would be useless. The threat actor could cause a lot of damage on the layer 2 LAN networking infrastructure. Okay, so what kind of attacks are there? And so security is only as strong as its weakest link in the system, and layer 2 is considered to be that weak link. This is because LANs were traditionally under the administrative control of a single organisation. We inherently trusted all persons and devices connected to our LAN. Today, with bring your own device and more sophisticated attacks, our LANs have become more vulnerable to penetration. All right. So there are several categories of attacks: so MAC table attacks, VLAN attacks, DHCP, ARP, spoofing, and STP attacks. So there's several MAC table attacks, but the most common one I think is the flooding, where basically they fill up the MAC address table of a switch, and then after that, it will actually then do flooding. If its MAC address table is full, it will actually flood all packets, frames, to all other ports, just to make sure that it gets to where it needs to go. All right. So with VLAN attacks, basically VLANs are wonderful, but they're not perfect, and there are some problems if you just use a default setup. And so you can do VLAN hopping and double tagging attacks. It also includes attacks between devices on a common VLAN. And so, yeah, there are ways around that. DHCP attacks includes DHCP starvation and spoofing attacks. I think we will talk about that. ARP, again, you can do some spoofing for MAC addresses and poisoning as well. And of course, spoofing again can be of course, for MAC addresses, but you can also have IP spoofing. And then when it comes to STP, you can basically manipulate who becomes the root of the tree, and so they'll actually see more traffic, and so that's another advantage for them. All right, so we will get into more details. I thought we were. Anyway, so there are some mitigation techniques that we can use, and so to prevent some of these attacks. And so port security is one of them. And so with port security, it prevents many types of attacks, including a MAC address flooding attacks and DHCP starvation attacks. So basically, you can control how many MAC addresses are permitted per port. And so if you limit to one MAC address per port, yeah, that makes the chances of MAC address flooding attacks happening much less. And so that's, of course, quite handy. Now, DHCP snooping is basically where a host pretends to be the DHCP server, and it will normally give itself out as being the gateway as well. And so then it will see all traffic. And so, of course, you can get your switch to snoop DHCP requests and replies, and it will only allow those replies from valid DHCP servers, which of course you need to have a known port number for that. So dynamic ARP inspection prevents ARP spoofing and ARP poisoning attacks. So basically with that, if someone's got some malware on a host, you can actually respond to every MAC ARP request with its own MAC address. And so then again, all traffic will go through it, and so they can snoop more stuff. So IP source guard prevents MAC and IP address spoofing attacks. So these layer 2 solutions will not be effective if the management protocols are not secured. The following strategies are recommended. Always use secure variants of management protocols such as SSH, SCP, SFTP, and SSL and the like. Consider using out-of-band management network to device manage devices. Use a dedicated management VLAN where nothing but management traffic resides, and use ACLs to filter unwanted access. Okay, so a MAC address a table attack. What does that look like? So recall that to make a forwarding decision, a layer 2 LAN switch builds a table based on the source MAC addresses in received frames. This is called the MAC address table. MAC address tables are stored in memory and are used to more effectively switch frames. So as you can see here, we've got 4 entries in the MAC address table, and each of these entries is dynamic, so it's learnt it through packets being moved, and you can see that it's recorded the ports, that the source port that packet with that source MAC address arrived on. So that's looks like a fairly standard MAC address table to me. But with flooding, all MAC tables have a fixed size, and consequently a switch can run out of resources in which to store MAC addresses. MAC address flooding attacks take advantage of this limitation by bombarding the switch with fake source MAC addresses until the switch MAC address table is full. When this occurs, the switch treats the frame as an unknown unicast and begins to flood all incoming traffic at all ports on the same VLAN without referencing the MAC table. This condition now allows a threat actor to capture all the frames sent from one host to another on the local LAN or local VLAN. Note, traffic is flooded only within the local LAN or VLAN. The threat actor can only capture traffic from within the local LAN or VLAN which the threat actor is connected. And so basically, this host is sending out different frames with the different source MAC addresses until it keeps filling until it fills the MAC address table. So from there, the switch will then flood traffic to everyone, which is not great. So what makes tools such as MAC-off so dangerous is that an attacker can create a MAC table overflow attack very quickly. For instance, a Catalyst 6500 switch can store 132,000 MAC addresses in its MAC address table. A tool such as MAC-off can flood a switch with 8,000 bogus frames per second, and so it only takes a few seconds to actually to overflow the MAC address table, and so that's when things go bad. Another reason why these attack tools are dangerous is because they not only affect the local switch, they can also affect other connected layer 2 switches, and when the MAC address table of a switch is full, it starts flooding out all ports, including those connected to other layer 2 switches. To mitigate these overflow attacks, network administrators must implement port security. Will only allow a specified number of source MAC addresses to be learned on the port. And we will actually, next chapter, we'll talk about how to configure port security. All right, other LAN attacks. So VLAN hopping. So the attack enables traffic from one VLAN to be sent by another VLAN without the aid of a router. And in a basic VLAN hopping attack, the threat actor configures a host to act like a switch to take advantage of automatic trunking port feature enabled by default on most switch ports. The threat actor configures the host to spoof 802.1q signaling and Cisco proprietary dynamic trunking protocol signaling to trunk with the connecting switch. If successful, the switch establishes a trunk link with the host as shown in the figure. Now the threat actor can access all the VLANs on the switch. The threat actor can send and receive traffic on any VLAN, effectively hopping between VLANs. So double tagging attacks. So a threat actor is in a specific situations could embed a hidden 802.1q tag inside the frame that already has an 802.1q tag. This tag allows the frame to go to a VLAN that the original tag did not specify. So basically, the first step is that they create a double tagged frame. The outer header has the VLAN tag of the threat actor, which is the same as a native VLAN on the trunk port. The frame arrives on the first switch, which looks at the 802.1q tag. The switch sees that the frame is destined for the native VLAN. The switch forwards a packet out all native VLAN ports after stripping the VLAN tag. The frame is not retagged because it is part of the native VLAN. At this point, the inner tag is still intact and has not been inspected by the first switch. The frame arrives at the second switch, has no knowledge that it was supposed to be native VLAN, and so the native VLAN traffic is not tagged by the sending switch as specified in the specs. A second switch looks at the inner 802.1q tag that the threat actor inserted and sees that the frame is destined for the target VLAN. The second switch sends the frame onto the target or floods it, depending on whether there's an existing MAC address in the table. So a VLAN double tagging attack is unidirectional and works only when the attacker is connected to a port residing in the same VLAN as the native VLAN on the trunk port. The idea is that double tagging allows the attacker to send data to hosts or servers on a VLAN that otherwise would be blocked by some type of access control configuration. Presumably, the return traffic will also be permitted, thus giving the attacker the ability to communicate with devices on the normal blocked VLAN. So how do we mitigate these things? VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines as discussed. So we disable trunking on all access ports. You disable auto trunking on trunk links so that trunks must be manually enabled, and be sure that the native VLAN is only used for trunk links. So previously we were talking about only having management traffic on the management VLAN. You should only have native traffic on the native VLAN, and so they should actually be separate VLANs. And so, of course, switch port mode access will disable trunking on those ports instead of having it dynamically figure out it's an access port. By doing the switch port mode access, you are manually putting it there, and it will not do that. And so, of course, you can do. You can also, of course, turn off your dynamic trunking. All right, DHCP. So, of course, DHCP uses DHCP discover, offer, request, and acknowledgement packets. That's your standard process. So, of course, that's how you learn your IP address, mask, gateway, and other such information. And so, of course, when it's working properly, all is good. When it's not working well, yeah, all is not good. So two of the major ones are you have your starvation attack. And so with that, the goal of this attack is to create a denial of service for connecting clients. And so basically, there's an attack tool called Gobbler, and has the ability to look at the entire scope of leasable IP addresses and tries to lease them all. And so from there, it basically sends out discovery messages with bogus MAC addresses. And so, so of course, from there, other hosts can't connect because it's all the IP addresses have been used. All right. So with spoofing attack, that's when they actually set up a rogue DHCP server, and it will give out false IP configuration parameters to legitimate clients. A rogue server can provide a variety of misleading information, including the following. So it might give the wrong default gateway, and so it allows them to create a man-in-the-middle attack. And so basically, it could, as I said earlier, say that it itself is the default gateway, even though it knows that it's actually what the true gateway is. And so it will actually pass on the traffic to the true gateway, but of course it will see all traffic going through the LAN, so that's not cool. It can give out the wrong DNS server, and so of course from there you might actually have a DNS server that will point you to the wrong places for different domain names, and so of course that can certainly be a risk. And with the wrong IP address, of course, they can't talk to the rest of your network, so that's not nice either. So that's more denial of service. Okay, ARP attacks. So hosts broadcast ARP requests to determine the MAC address of a host with a destination IP address. All hosts on a subnet receive and process the ARP request. The host with the matching IP address is, of course, the one that sends the reply. A client can send an unsolicited ARP reply called a gratuitous ARP. Other hosts on the subnet store the MAC address and IP address contained in the gratuitous ARP in their tables. And so an attacker can send out a gratuitous ARP message containing a spoofed MAC address to a switch. The switch would then update its MAC table accordingly. In a typical attack, a threat actor sends unsolicited ARP replies to other hosts on the subnet with the MAC addresses of the threat actor and the IP address of the default gateway, effectively setting up a man-in-the-middle of attack. There are many tools available on the internet to create man-in-the-middle attacks. And so IPv6 uses ICMP neighbor discovery protocol for layer 2 address resolution. And so it does have some strategies to mitigate neighbor address spoofing, similar to the way IPv6 prevents a spoofed ARP reply. ARP spoofing and ARP poisoning are mitigated by dynamic ARP inspection. So address spoofing attacks. With IP address spoofing is when a threat actor hijacks a valid IP address of another device on the subnet or uses a random IP address. IP address spoofing is difficult to mitigate, especially when it is used inside a subnet in which the IP belongs. MAC address spoofing attacks occur when the threat actor alters the MAC address of their host to match another known MAC address. The switch overwrites the current MAC table entry and assigns the MAC address to the new port. It then inadvertently forwards the frames destined for the target host to the attacking host. When the target host sends traffic, the switch will correct the error, realigning the MAC address original. To stop the switch from returning the port assignments to its correct state, the threat actor can create a program or script that will constantly send frames to the switch so that the switch maintains that incorrect or spoofed information. There is no security mechanism at layer 2 that allows a switch to verify the source of MAC addresses, which is what makes it so vulnerable to spoofing. IP and MAC address spoofing can be mitigated by implementing IP source guard. Okay, spanning tree, or STP. So network attackers can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology network. Attackers can then capture all the traffic for the immediate switch domain. To conduct an STP manipulation attack, the attacking hosts broadcast STP bridge protocol data units containing configuration and topology changes that will force spanning tree recalculations. The BPDU sent by the attacking host will announce a lower bridge priority in an attempt to be elected as the root bridge. This STP attack is mitigated by using BPDU guard on all access ports. We talk more about this later. Now, CDP. I think we talk about CDP in the last chapter, but anyway. So CDP is Cisco Discovery Protocol. It is a proprietary layer 2 link discovery protocol. It is enabled on all Cisco devices by default. Network administrators also use CDP to help configure and troubleshoot network devices. So CDP information is sent out CDP-enabled ports in periodic, unencrypted, unauthenticated broadcasts. And so the information includes the IP address of the device, iOS version, platform, capabilities, and native VLAN. The device receiving the CDP message updates its CDP database. To mitigate the exploitation of CDP, limit the use of CDP on devices or ports. For example, disable CDP on edge ports that are connected to untrusted devices. To disable CDP globally on a device, you can do no CDP run. Of course, to turn it on again, it's CDP run. You can also do on individual ports by using no CDP enable. And so that would actually just disable on the ports that you wish to disable it on. Now, CDP, Cisco Discovery Protocol, is Cisco proprietary, hence the C. There is actually a standards-based version of it called LLDP, and that is just as vulnerable to attacks, but I think its use is less common. And so you can do no LLDP run to disable it as well. And you can do the no transmit or receive commands on individual interfaces. Okay, we've hit the end of the chapter. So what did we talk about? So we spoke about endpoint security. And so they're particularly susceptible to malware-related attacks that originate through email or web browsings. And they're also distributed denial of service, data breaches, and malware. These endpoints have typically used traditional host-based security features such as antivirus, anti-malware, host-based firewalls, intrusion prevention. Endpoints are best protected by a combination of NAC, host-based AMP software, and email security appliance and web security appliance. AAA controls who is permitted to access a network, what they can do while they are there, and audit what actions were performed. And so that's, of course, authenticate, authorize an account, or AAA. There is also 802.1x, which is a port-based access control. and Authentication protocol that restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. If layer 2 is compromised, then all layers above it are also affected. The first step in mitigating attacks on the layer 2 infrastructure is to understand the underlying operation of layer 2 and their layer 2 solutions. So port security, DHCP snooping, DAI, and IPSG are ways that we mitigate these layer 2 threats, but of course you also have to make sure that the management protocols are secure, so SSH and the like. MAC address flooding attacks bombard the switch with fake source MAC addresses until the switch MAC address table is full. A VLAN hopping attack enables traffic from one VLAN to be seen on another VLAN without the aid of a router. Double tagging is a unidirectional and works only when the threat actor is connected to a port residing in the same VLAN as the native VLAN. VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines. So, manually put all access ports in access mode. Don't have dynamic trunking, and be sure the native VLAN is only used for trunk links and not available for host ports. Two types of DHCP attacks are starvation and spoofing. Both attacks are mitigated by implementing DHCP snooping. So ARP attacks, where a threat actor sends a gratuitous ARP message containing a spoofed MAC address to a switch. The switch updates its MAC address table accordingly. Now the threat actor sends an unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. ARP spoofing and ARP poisoning are mitigated by DAI. So address spoofing attacks are where basically you pretend to have someone else's address, be that IP or MAC. MAC address spoofing is when threat actors alter the MAC address of their host to match another known MAC address of the target host. And so IPSG will help you mitigate the addressing spoofing. STP attacks are where basically someone tries to be the root bridge and then they'll see more traffic. And so there is actually BPDU guard that will protect you from that. And then CDP Reconnaissance, of course, gives you information about what devices are where. And so it's very good for reconnaissance. It's also very good for fault finding if you're on an unknown network. But anyway, so there are some risks with that. And so it's unencrypted and unauthenticated information that goes out there. So you've got to be careful with CDP. And there is the logo. I'll see you for the next chapter. Have a good one.